Okay, so we're using our ability from yesterday to solve logarithmic equations to try to do some problems that have to do with a thing called radioactive decay. So I don't want to get too sciencey over this, but there are things on the periodic table, elements that are radioactive, which means they basically decompose into other things. Like uranium is radioactive. I think you know you don't probably want to handle uranium or plutonium. Like these are things that are like, they're called radioactive. Sometimes they can make weapons out of them, but that's not what that means necessarily. Radium is another thing that's radioactive. You might have heard of Pierre and Marie Curie, famous people from science. They did all these experiences with radium, and then they ended up, Marie Curie died of radiation poisoning because that was radioactive. But there are some elements that are radioactive. Like oxygen is not. Oxygen is just oxygen, it stays oxygen forever. But radium gives off radiation and it turns into other stuff. I don't know off the top of my head what it turns into, but I'm pretty sure plutonium eventually turns into uranium, and then uranium turns into other things. But the idea of a measurement of radioactive decay is there's a thing called, every element that's radioactive has a thing called its half-life, and that's the basis of today's math. The half-life is simply the amount of time it takes for half of a radioactive substance to decay. So, for example, if this chalk were radioactive with a half-life of 10 minutes, that means if I'd walk away for 10 minutes and come back, I wouldn't have a full piece of chalk. I'd have half a piece of chalk. Then if I'd walk away for another 10 minutes, I could come back and it wouldn't be this size, it would be half of that. And then if I'd walk away again, I'd come back, it's half again, it keeps cutting in half. Some of these problems we're going to need to do some equations with. Other problems we can common sense, kind of like this little table I'm about to build you. So here comes a little table. If I tell you the half-life of something is 2 days, and I have 1,600 grams now, the next time I should come back and check on that would be in 2 days. And when I come back and check, I wouldn't have 1,600, I'd have 800. Then after a total of 4 days, I'd have 400. And in 6 days,
you'd have
200. And in
8, you'd have 100.
I'd have 100. And in
10,
I'd have
50.
And in
12, 25.
And we could do that forever, but I'm running out of board space. Over here we keep counting by 2s because that's a thing called half-life. That's the key to the whole operation. And over here we just keep cutting it in half, hence the name half-life. So if I ask you questions about 2 days, 4 days, 6 days, 8 days, 10 days, 12 days, you can just common sense that without too much heavy lifting math. But if I ask you in 3 days, you couldn't do that without math. The 3-day answer would be somewhere between 800 and 400, but it wouldn't be dead halfway. It would not be 600. It would be somewhere, maybe it's 650, maybe it's 5, something, just somewhere in between. But question about the idea of half-life and what's going on. Again, not to get too sciencey, but this stuff isn't just disappearing, it's turning into other things. There's a thing that the law of conservation of energy that I'm sure you've all heard of at some point in science that says matter can't be created or destroyed, but it can turn into other things. So, my chalk, if it were radioactive, which it isn't, when I had half of a chalk, the other half would become energy or uranium or something else. It would just change. Question about the idea? So here's the equation of the day. Again, about half the problems you're going to have to use equations. And about half of them you could common sense them if you want to. But if you want to use the equation way would always work. The common sense way, like half of them. Okay, so here's the equation we're going to use if we have to use an equation. It's y equals yo, e is our number from yesterday, negative power of kt. And here's what these variables mean. The y is a measurement of how much stuff you have right now. So in this story, that would be the like 25, the 50, the 100, the whatever that might be that's like on the move changing. The yo is your original amount you started with, which in this story would have been
16.
the 1600. E is just a number from yesterday. Doesn't matter what it is, because even if you don't know what the number is, who knows what the number is? The calculator knows. So we'll go get that from that. It's a negative power. This K is what we're going to have to math out a lot. The K is going to be different for every problem. Every situation, every scenario, the K is a different thing.
So, real quick question, because on your video, I know it was filmed during COVID, and you
Yeah.
said about using papers and things to help you.
No, that's not valid.
I didn't think
Yeah.
so I just wanted
Correct.
to double check.
True story. The K is going to be different for every scenario, and the T, as you probably expect, would stand for time. Okay. The little t is a time that could be any time in the universe. The half-life is always going to be a capital T. The variable for half-life is always capital T. And then any random other time is just little t for time. Two other side equations, you're going to need to write these down and have these somewhere. And someday when you take a test, they need to be in your memory. To figure out this K that's different from every problem, the K is going to be the ln of 2 divided by the half-life. Or if you're ever asked for the half-life in reverse is the ln of 2 divided by the K. But that's three equations. You need those. You need those on your paper to do tonight. You need those in your brain to do a test someday. Question about idea and information. And I'll stroll my cameraman to the left. So if I tell you the half-life is 12 days, and I have 400 grams of stuff at this moment, and I'm going to say, go! And I want a count in 36 days from today. Do we need serious math to do that, or can I just go make stuff cut in half, table stuff? I can just cut stuff in half. Because if the half-life is at 12, I can successfully measure at 12, then again at 24, and again at 36. And I'm trying to land on 36, so I made this question to work out kindly to you. You don't need heavy-duty math to do this. So if there's 400 grams at this second, my first check back, we'd have 200, then 100, then 50, and that's what we're hunting. Question about that game. Okay, if I want to know 37 days, no, we've got to do some math. So the most important fact you need to generally figure out before you do anything is the K. So over there I had an equation. How can we get the K? What was K equal? ln of 2 divided by the half-life, which in this case is 12. Let's punch that in. And I would suggest, even better than writing it down, store it in your calculator. So if you punch this in, it's going to be an 0577, but it fills your whole screen. So punch some buttons. Anybody not see an 0577? Sorry. We're going ln of 2, it's divided by 12. We're hoping a .0577 shows up.
For some reason, he keeps adding a 3 at the end, so it's making it 123.
I got it.
Every time I do it, like, it like makes what I'm dividing 123 instead of 12. You see what I mean?
Yeah.
Like, I don't understand why it's doing that.
I don't either. We're going to just set that aside. And
Because you put 12 and you hit enter, and then it gives you the answer for 123, and that's 3.
I'm not going to throw this one. Can you pass that back toward his area?
I can't get 0577.
So I would type. So I would type this.
So go ln
As soon as I can hit enter.
2.
like this.
Close it, divide by. Okay. Anybody not able to get to 0577? I don't think you're going to want to write down what's on your whole screen. You can, if you have trouble with the buttons we're about to push, you could write down that whole thing to type it back in later, but I think that's annoying. So the calculators have a feature to store things. So everybody should have a button that says STO or something like that. Okay, so hit your STO button. If you have a primitive calculator like this one, not primitive, but medium style calculator like this one wants me to choose A, B, C, D, or E. I would just choose A. You would choose A, I think, by just hitting enter, and that's like stored there. Yours might only have one storage location. The backwards calculators have one storage location. You just probably hit store and it's stored. If you have one of the fancier calculators, you hit stow, and then you're going to have to use a letter button. I think, do you have right here, is it yellow for you?
Yeah.
Okay,
Second.
so then do you have below that a green?
I do.
Okay, so does the green say something like it's an alphabet?
Yeah.
So you're going to go green button, and then you're going to pick a letter. You might as well pick K, because that's what it is. K is in green somewhere on here. So you go store, letter button, pick the K, hit enter, and now we're calling that K. Anybody not with the storage? Okay. So then let's do math. So the equation we had over there, there's a future amount of stuff we don't know. After the equals, we always want the original amount of stuff, which we do know in this story. It's original amount is
400
400.
Yeah.
There's E, there's negative, there's K, which we know. I'm just going to put K because that's what we just stored. I don't really want to write this number out. That's why we stored it. So that number is what K is. And we know a T. What's our T? What's the T in this story?
Oh, 37.
37. Question about how I knew which number went where. Algebra easy or algebra difficult? To solve for the variable? Get the variable alone? Easy or difficult? It's already alone. So that's definitely easy. All you're going to have to do is push some buttons. So buttons we're looking to push here would be 400 times. Does anybody remember how we accessed the E yesterday?
Yes.
How do we do that? The colored button, which is probably second, and ln, because in a color it's probably written E. It starts you with parentheses. So you would do the negative button. Then we're going to want to recall that. So to recall that, you should have a recall button. On the nice calculators, you have a button, I think it says recall.
RCL.
Probably RCL. So you'd recall maybe it shares a key with store if you don't have a button for just recall.
Yeah.
So if it shares a button with store, you'd go color button, the store button, which recalls it, and then you have to remember which letter you picked. The medium people, I told you guys to pick A, so pick A. The fancy people, I told you to pick K, so get your K going again. And then times 37. Close the parentheses. And if you do this perfectly, it's going to be 47.19. And then I cross my fingers and hope in a group of 15 people that it goes 15 for 15. But you know somebody pushed some funny buttons because there's too many people.
I pushed 20 minutes.
Okay.
I don't know what I'm doing.
Let me trade you for a day a calculator.
I was about to say, yours is backwards, so you probably hit the right buttons. But
Let me trade you a calculator that you don't have to push all the buttons backwards. So here's what we
oh yeah, I got it. do a 400. And then the E, so you set the LN.
I just gotta figure out how to make it with my calculator.
And then
I don't calculate it.
the negative, and then you go the alpha, hit the whatever one, it does K. Okay, so you go alpha K. Times 37.
My batteries are all dead. How about if we just troubleshoot you later? You have like a tip for your study hall or
Yep.
something? I'll find it. I'll come on. We'll troubleshoot. Anybody else will need any troubleshooting, or did that work? Okay. I might have to troubleshoot you later, because I don't. So let's go another story, just in the interest of time. So if there's 12 half-life, 1,000 grams, and we're figuring out when in the future we're gonna hit the 125 line. Just try to like mentally do that. Are we gonna run into 125s if we start from 1,000?
Yes,
Yeah, because 1,000 turns into
500.
500, turns into 250, turns into 125. So if our half-life is 12, this check would have happened at 12, then
36, or 24.
24,
36.
answer is 36, so 125. So that one just sort of worked. Something about that. So let's go up one. Half-life of 12, 1,000 grams again. Is that little list, if we kept going, gonna land on 70?
No.
No, so we need to just do some math. Do we need to figure out the K? I'm gonna say no, because
We already did.
we already did. And what did we do with it?
Sort
We
of.
stored it. I didn't change this. If this weren't a 12 anymore, then we'd have to go ln of 2 divided by the new number, get a new K, store it in a new spot, all that kind of stuff. But since I stick with a 12, we don't need to do that math. We'll just use the thing that we had before. So just jump into the equation. Do I know the future amount of stuff? Before the equals is like the, we know a 70 at some future point. Do we know the original?
Yes.
Yes, 1,000. We know an E, we know a negative, we know a K. We don't know the T. The T is what we're hunting. T is the unknown, because it asks us when.
So we're trying to get the T
We're
alone.
trying to get the T alone correct. Question about that? So how would we use algebra skills from yesterday to get the T alone? Eventually ln, but right now we can't jump on the ln because something else is in the way.
Do you flip turn into a log first?
No?
I don't know what LN means.
What's in the way of a divide the 1,000? LNs can kill E's, but right now 1,000 is like mucking that up. So we need to go 70 dividing 1,000. That's going to be a 0.07. That equals e to the negative kt. Then everything in math has an opposite. You are here for the lesson, but the opposite of e is a button called ln. So to kill e's, we'd have ln of 0.07 is negative kt. To get the t completely alone,
You have to get the K out.
we have to get the k out. How's k going to get out of there? Divided. So we have ln 0.07 dividing negative k, and let's push the buttons. So we're going to go ln of 0.07, close the parentheses probably after the 7, divide by, do the negative button, and recall your k again. The same way you recalled a k 5 minutes ago, we're recalling another k. If you push buttons right, we're hoping for a 46.04. Seems like some positive feedback.
Yes.
I got the 46.
Okay.
But I don't have the recall button working. So
Okay.
I just typed it in.
Worst case scenario, if you can't get the recall button to work, just write that whole number down, punch it all back in. But if you can do the store and recall it, it's kind of nice.
I have the buttons. I just don't know how
You
to
can't
do
get
it.
it. Okay, I'll play with it. Every calculator's a little different, so it's hard for me to, it's hard for me to give advice to a room and everybody it's gonna work the same way, because the machines are all a little bit different. Something there? So here's a different kind of setup. There's 600 grams now. We're gonna have 150 grams in 20 days, and we're trying to figure out what the half-life would be. Does it seem like one where we make the table and the halvesies, the numbers are gonna like bump into each other?
They will?
They will, because 600 turns into 300, turns into
150.
150. This is at a 20-day mark. That was like the start. This is like the 0-day mark.
10?
So this would be a 10-day mark. So it's cutting in half every
Okay.
10 days. Something about that? Hey, was 100 ever going to show up in that list? No. So we've got to do some math again. So if we go to that equation, where's the 600 going to go?
Now is over by itself. It is 600 now. Oh no, the 600 original?
Is the original. 600 is the original, so that goes
Right side?
on the right side. So where's the 100?
On the other side.
On the left side. If you're not sure, the original number always has to be bigger than the later number, because the stuff's going away. Then E, we know that.
Negative.
Negative, because it's going down.
Okay.
K, which we don't know. T, which we do know, is 30. Question about that. Okay, the only thing we can solve for that we don't know is the K. So we're going to try to solve for the K. How can we solve for the K? Not ln yet.
Get
You want
it
to get rid of the 600?
We need to get rid of the 600. So 100 divides by 600. If you want to push fewer buttons, 1/6 is the same as 100 dividing 600. So 600 out by division. ln kills E. Wrap that up in parentheses.
You divide by 30.
You would divide by not just 30, but negative 30. Question about that math. Let's push some buttons. So if we push those buttons, we're hoping to show up a .059 kind of thing. .059 showing up for anybody? Yeah. Positive feedback. Anybody trouble showing up to 059? That's not the answer. We're close. We're very close. We're going to want to store that. Store that. Pick your favorite letter. Doesn't matter what letter you pick, but store that somewhere. How are we getting the T? We have an equation for capital T. Capital T behind me. ln of 2 divided by
Divided by the number that's
the number we just stored. So we're going to go ln of 2 divided by the number we just stored, and I'm hoping you get an 11.61. So from there, one more scenario. So I tell you, there's a half-life of 6. We're going to check in at the 24-day mark. When we check in at the 24-day mark, we have 50 grams. With half-life of 6 and a 24-day check, can we common sense this?
Yeah.
Yes. Okay, so we have a now. We could check in 6 days, 12 days, 18 days, 24 days. At the 24 day, we have 50.
So it's gonna.
So at the prior level, it was 100,
200,
200,
400,
400,
800.
800. So, something about that. Is 27 gonna fit in with 6? No. So, do some math. We have the later on down the line amount,
80?
80. Original amount,
You don't know.
don't know it. E, negative.
KT.
K we can get in a minute. We didn't get the K yet, but we can get it. The T
27.
is 27. How can we get the K before we really do anything else?
Why don't you just use the equation?
Which equation?
The,
ln of
It's like 0.11.
it would be ln 2.
2 over, in this case,
27.
6. The half-life is what we use for that. So if you push those buttons, it's a 0.11 kind of thing. Store it, because it's a pain to punch those numbers in all the time. Anybody trouble getting out 0.11? Then we want to solve for x, and that's not going to be too bad. Because the x is doing what to this? Multiply. So you're just going to have to divide. Take 80 and divide by that thing. 80 divided by, anybody need a reminder how to get your E button going?
Well, to me.
Second ln. Yeah, the 80 divided by the E button. And it'll have parentheses for negative, recalling this, times 27. And that's going to be an 1810-ish, 0.19.
What is it?
1810, I'm hoping, 0.19. Did that show? I saved the easiest for last. I have one more cluster of problems, but these are easier than what we just did. Question about anything we just did? In this same mix, there's a thing called carbon dating. I don't know that I have time today to explain the ins and outs of carbon dating, but it's basically trying to figure out how old something is. You got a fossil, you want to know how old the butterfly was before it got fossilized. There's a thing called carbon dating you can use to try to figure it out. It sort of works, it's sort of hokey, but I don't have time to go on a big rant. We'll save that for another time. But the equation that does this, you figure out the percent of carbon that the thing has left in it, and it equals the same thing we've been equaling in a bunch of these other problems. E to a power with a negative K and T. The K for these with carbon is the ln of 2 divided by 5,700, because 5,700 years is the half-life of carbon. So if you want to punch this in and maybe store it in another letter, maybe put it in C for carbon, and not put other things in C for carbon, then anytime you have a carbon question, that's already stored there for you. But this K, ln of 2 divided by 5,700, if you want to push those buttons, its scientific notation will show up. It's 1.21 times 10 to the negative fourth. So punch that real quick, probably. ln of 2 divide 5,700. Hope that shows up. Store it in maybe C for carbon so you don't confuse that with other things you've been using all period. Any trouble with that part? Yeah. So I could tell you one of two things. I could say something like 21% of the carbon is there. Or I could do another question where I say something like 14% of the carbon is gone. The equation works based on the percentage of carbon that is there, that's left. So if I tell you there's 21% of the carbon there still, you'd what? 21%, which is best to usually put as 0.21 equals E negative K, which we know, T is what we hunt. So here's another formula, make sure it's on your page somewhere because you'll need that. Question about setup. So how would we solve this? We're after the t. Kill e with ln. And then to get rid of the negative k, divide. So ln of 0.21, divide by the negative button and the k that you probably stored in C if you were following my advice. That is 12,833 years ago. And I don't buy that. I'll save you the rant for another day. Something about that. If 14% is gone, that means that 86% is left. So 0.86, e, negative, k, t. Again, we're hunting the t. So how do you kill e's? ln. How do you get the negative k out of there? Divide. So ln of 0.86, divide the negative k that we stored. This is ballpark 1,240 years ago. I'd say maybe on that. I might buy that.